Welcome to this instructional video on solving a system of linear equations using tables. We will be using a TI-84 graphing calculator, but the directions would be the same for a TI-83 graphing calculator as well. The example we will be working with is to solve the system of linear equations that are y equals 6x plus 4, y equals 8x minus 6, and y equals negative 2x plus 44. To get these equations onto your graphing calculator, we need to put them under the y equals button. So after hitting the y equals button, we can type in 6x plus 4. That is our first equation. We will enter that. Our second equation is 8x minus 6, and we can enter that. And our final equation is negative 2x plus 44, and we will enter that. Now, for this to be solved using tables, we need to use the table function of our calculator. Notice it is the same as the graph button. However, since the word table is written in blue, we need to hit second and then the graph button for a table to show up. Now this table is defined to count by ones and to show our equations. If this is not how you want your table to be set, notice there is a table set button that is the same as your window button. If we hit second and table set, this allows us to start our table at any value we would like. I am going to change this to start at negative 5. And then as we hit enter, the second row has a triangle with a TBL by it, which means change in your table. When this is a 1, we'll count by 1s. If we put a 2 here, we would count by 2s. You could also get more specific and use something like 1/10 to count by 1/10 each time. But now I have changed this for my table to start at negative 5 and to count by 1s. Notice now when we go back to our table that we started with an x value of negative 5. Now to solve a system of equations, we are looking for an x value and a y value that all of the equations have in common. So what we're looking for is for y1, y2, and y3 to have the same answer. We cannot see y3 right now. If we would like to see y3, we need to use our right arrow button so that we can see y3. Notice it will keep showing the x value and now y2 and y3. So if I go back to the left, it will show me my x values y1 and y2. Once again, we are looking for the similar answer. I do not see it at this point. If I think the answer is more negative, what I need to do is to make sure that I get to where my x values are highlighted. Then I can use my up arrow to explore further negative numbers. As you can see, the answers are getting farther apart, so that is not the direction I want to go. So therefore, I am going to use my down arrow and hopefully find answers getting closer together. As you can see, we are getting quite close together, and now when we are at x equals 5, notice the first equation and the second equation both have an answer of 34. If this is truly going to be an answer to the system, all the equations need an answer of 34. So as we scroll to the right, we notice that y3 is also 34. So we have found the answer to the system. It is when x is 5 and y is 34. If we wanted to verify this on a graph, which is something you should have learned in a different video, we could go to second and calculate. We want to calculate the intersection point. So we will go to the intersection option and hit enter. Now intersection only works for 2 equations at a time. So once the graph appears, it will ask me for the first curve, which is my first line. I will hit enter to accept that. Now the cursor is blinking on the second line. I will hit enter to select that. Now the intersection is only for 2 points, so it's asking for my guess of where they cross. And so I will just keep moving my right arrow until I get close to the intersection points. It does not need to be perfect, but close. I will hit enter and find out that the intersection point is in fact 534, which matches what we saw on our table, which if I go back to the table, you will once again see that the answer in common is when x is 5 and y is 34. That is the solution for the system.